Assalamu alaikum. Welcome to our presentation about multivariable linear regression assignment. Myself, Sheikh Nafez Sadnan, ID 20101106, along with me my teammates Mohammad Asadujjaman Noor, ID 20101101, and Mohammad Enan and Harun, ID 20101095. So, for the assignment purpose, at first we need a dataset. We have fetched our dataset from here. As we can see, hepatitis C virus for Egyptian patients. So this was our data set, and we have implemented it using with sklearn and without sklearn, and we have also measured the values. So for the assignment purpose, at first we need to know what is sklearn. It is a machine learning library for Python that features various classification, regression, and clustering algorithms, including support vector machine, random forests, gradient boosting, k-means, and dbScan. So for the assignment, at first we have imported some features. As we can see, we have first imported the NumPy. NumPy is a popular Python library for numerical operations. Then we have imported Panda. Panda is another Python library that is very popular, and we used it for data manipulation and analysis. We import train test split function from sklearn. It is splitting the dataset into training and testing subsets. Then here is standard scalar. This class is used to standardizing features. Then we have linear regression class. From sklearn metrics module, we have imported mean squared error and R2 score function to evaluate the performance of the regression model. And at last we have imported the matplotlib, the popular library for creating plots and graphs in Python. So to implement the sklearn, at first we have loaded our dataset from the CSV file. As we can see, the dataset was here. We have downloaded it and we have imported it. Then we have two variable. One is x, that is independent variable, and another one is y, that is dependent variable. So as we can see, independent variable x contains all the columns of the dataset except the baseline histological staging, and y dataset that contains the value we want to predict. Here 0.2, as we can see, 0.2 test size. That means 20% data is for testing set and other 80% data will be used for training. And here we have random state of 0 to ensure reproducibility, to get the same split every time we run the code. Then we have created a linear regression model and fit it to the training data. We made predictions on the test set. Then at last we have evaluated the model's performance. Here some things to be noticed: that mean squared error, it calculates mean square error between target value y test and predicted value y predict sk. This is actually a measure of the average squared difference between predicted and true values. It quantifies how well the model prediction matches the actual data. Then we have R2 score, that is a statistical measure of the proportion of the variance in the dependent variable that is explained by the independent variable in the model. R2 ranges between 0 to 1, where 1 indicates a perfect fit. And here we have the mean squared error and R squared result out as an output. The rest of the code will be discussed by my another two teammates. Thank you so much for giving me the opportunity. Thank you.
Hello, this is Mohammad and Harun Sahan. My previous partner discussed about implementing linear regression using sklearn. Now I will be explaining about implementing linear regression without sklearn. To implement linear regression without sklearn, we first use the hypothesis function. The function is given here. In the function, y represents the dependent variable and x represents the independent variable. Both y and x are 2D matrix variables. Using our hypothesis function, we will then find out the value of the beta. To find out beta, we will first multiply x with its transpose matrix, then inverse the result, and then multiply the result with the transpose matrix of x. Then multiply this result with y. Beta will help our model predict the value of x from the text data. We will compare y from the hypothesis function with our actual test data to figure out whether our model result is correct. Considering that result as a base, we will then find out the MSE, mean squared error, or and the R squared error. These are the formulas that we will be using to implement our linear regression and find out this result. The rest will be discussed by my partner Asadujjaman Noor. Thank you for the opportunity, sir.
So now we will implement our multiple linear regression without sklearn. So we have to build our test data and train data, which is converted to the NumPy. Because of we have to calculate in matrix. So firstly, we will calculate our train x and calculate the coefficient using the formula, which is we'll discuss previous. And here is the test data prepare, and we will get the test data output. Then we will here calculate the mean square error and R root score. So here is we can see the mean square error and R square root. And here is the plot, which is show the test data and predicted data of sklearn and without sklearn. So we can see here the both data point are overlap as similar as sklearn and without sklearn. Thank you.
Hello again. This is Mohammad Enan Sahan. I will now be talking about the dataset that we have chosen for our linear regression model. Our dataset is based on a hepatitis C virus or HCV for Egyptian patients. Our dataset has 29 features. The feature starts from age, gender, BMI, fever, etc. The several symptoms of HCV virus, and this is the final grading that we are using for our Y value. This is baseline histological grading. Now, if I look at the main dataset, the dataset starts from age, and there are 29 columns including our dataset in our dataset, and there are 1386 rows. Our Y column is baseline histological grading, and every other column has been used as X.